Welcome back to Code. 3 episodes in, and we have quite a collection. A flashlight blinking across a dark street, dots and dashes running down a wire, 6 small bumps, red with a fingertip, every one of them built from the same 2 states, on or off. But we have been quietly cheating. Because a code by itself is only an agreement. It cannot cross a room, it cannot travel down a wire, it needs something underneath it, something physical, to carry it. So tonight we stop talking about the message and take apart the messenger. One flashlight, unscrew the cap, tip out the batteries, lift out the bulb. There is almost nothing in here. And yet somewhere among these few dull parts is the beginning of every computer ever built. Throw away the case, the reflector, the spring, all the tidy engineering. Keep only what we truly need. 2 batteries, 1 bulb, a couple of pieces of wire. Now hold the bare ends of those wires apart, and nothing happens. Touch them together, and the bulb lights. That is the entire flashlight. Everything else was a comfortable handle. And look at the shape of what we just made. Out of the battery, along the wire, through the bulb, and back to where it started, a loop. No beginning, no end. We call it a circuit, and that word is the clue. A circuit is a circle. Now watch what happens if I break it, anywhere at all. Cut the wire here, the light dies. Cut it over here, same thing, just loosen the bulb, and out it goes. The path has to be complete, the whole way round, which makes that last part a strange little invention, because a switch is nothing more than a gap in the circle that you are allowed to close. A circle suggests something is going round it, so what exactly is moving? For that, we go very small. Everything around you is built from atoms. At the center of every atom sits a dense little core, with electrons out around it. Those electrons carry a charge we call negative. The core carries the opposite, positive, and opposites want very badly to be in balance. Pull electrons away from where they belong, and you have made an imbalance. Nature will correct it, the instant you give it a path. You have felt this. Scuff your shoes on a carpet, reach for a doorknob, and snap. That sting is electrons putting themselves right all at once. Lightning is the very same event, enormously more of it. But the bulb in your hand doesn't flash once and stop. It glows steadily for hours. Because inside a wire, nothing is sprinting anywhere. Picture a tube already packed full of marbles. Push one more in at this end, and one drops out the far end straight away. Nothing raced the length of it. It is a queue, shuffling forward, together. So what starts the shuffling? The battery. Inside that tube, a slow chemical reaction is piling up spare electrons at one end, and leaving the other end hungry for them. And that pressure, sitting there, waiting, that is voltage. Here is the part worth holding on to. The pressure is real whether or not anything is connected. Picture a reservoir behind a dam, gate shut. Nothing is moving, but the height of that water is absolutely real. It is potential, work that hasn't happened yet. Your flashlight battery holds 1.5 volts of it. Stack 2, nose to tail, and you have 3. Now open a path and the pressure finally does something. Electrons move. How many sweep past every second? That is the current. And the path pushes back. Every material resists a little, which is called resistance. 3 quantities, and they lock together into one tidy sentence. The current you get is the pressure, divided by the resistance. Push harder, more flows. Squeeze the path, less flows. That is the whole law. A man named Georg Ohm worked it out 200 years ago. Which lets us answer something we have walked straight past. Why does the bulb glow? Start with the wire. Copper. Copper is generous with its electrons. They come loose easily and travel without much of a fight. A material like that we call a conductor. The plastic wrapped around it is the opposite. It grips its electrons and lets nothing through. An insulator. So the metal is a corridor, and the plastic is the wall. And then, inside the bulb, that corridor suddenly narrows. Coiled up in there is a thread of tungsten, far thinner than the wire feeding it. the same crowd of electrons must now force its way through a much tighter space. They shove, they collide, and all that shoving comes back out as heat. Push hard enough, and the thread gets so hot it glows, white hot, and throws off light. That is all a light bulb is, a piece of wire made deliberately difficult, sealed in a little glass vacuum so it can burn hot without burning up. The light in your hand is resistance, made visible. And go the other way. Join a battery's two ends with bare wire, no bulb, no resistance at all. And everything arrives at once. The wire heats, it can melt. That mistake has a name, a short circuit. Which leaves one part, the one nobody thinks about, the switch. It is the least impressive object in the whole flashlight, a scrap of springy metal that either touches or doesn't, and it decides everything. Now, a small oddity. When a switch is letting electricity through, engineers say it is closed. When it is stopping it, the switch is open, which is backwards from every door you have ever walked through. Closed, open, on, off, and there is nothing in between. The bulb does not sit there half lit, making up its mind. The circle is complete, or it is broken. Now hold that up against everything we have built. A flash or darkness, a dot or a dash, a bump or a flat space. And now, a circuit, closed or open. For 3 episodes, our codes have been ideas, marks on paper, agreements between people. Tonight, for the first time, we are holding a physical object. That is a code. One switch, one choice, one bit. And that is the hinge this whole series turns on. Because if a circuit can be a code, then a machine can carry one. Next time, we run our wire further. Much further. 2 houses a long way apart, 1 line between them, and a problem nobody sees coming. Next time, the long wire.